today we were talking about the 5th lesson in our probability and statistics unit, random samples. The homework that goes along with this is page 13 to 16 in your homework packet. All right, open up to page 15 in your note packet. We're actually going to go through some of these notes. Most important ones I want you to highlight. You can spend time reading this, okay? But I'm going to go through part of it. Okay, the population that you are surveying, that is all of the people. So if I'm doing a survey and I want to find out what the favorite lunch is of all the students at Junior High West, the population is the people that you want to survey, so all students at Junior High West. And then out of that population, I will pick a sample. And the best kind of sample is a random sample. And this is super important. For a sample to be random, every member of the population has to have an equal chance of being selected. Every member of the population has to have an equal chance of being chosen. Okay. The members of that representative sample must represent the whole group. Now, once you have your survey, your population, which is the whole group, and then the random sample, that's the part you're sampling, you can make inferences about your results. So the cafeteria lunch ladies could figure out how much of each type of food they need to buy based on preferences. But if you have a biased sample, it won't be representative. So, for instance, if I only surveyed my students, let's remember the definition of a random sample. Every person in the population has an equal chance of being chosen. Well, if we only survey my students, I don't teach every kid in the school. So that would be a biased sample, because the only way you would get picked for the survey is if you were in my class. Now, let me give you another example. What if we want to do a lunch survey of the students at Junior High West? We're going to ask them what their favorite lunches are. And I decide to survey every 5th student walking into the school in the morning. Well, everybody in the school has to come in to the building. And don't they all have an equal chance of being picked? So that would be a random sample. But what if I said, I'm going to only survey people that are going into the nurse's office? Well, not everybody goes into the nurse's office every day. So it would not be a random sample, because not everybody has a chance of being chosen. So for it to be random, every person has to have an equal chance of being chosen. Let's take a look at these examples. Mark wants to estimate the average age of vehicles in his town. He reviews a list of registered vehicles and notices that there are many more cars than trucks. Then he creates a sample by randomly choosing 100 cars and 100 trucks from the list. Did Mark select a representative sample? Why or why not? Well, let's think about it. The population, all vehicles in a town. Then it tells you that there are more cars than trucks. So, if he samples 100 cars and 100 trucks, is that going to be a representative sample? No, because they told you straight up there's more cars than trucks. So, if you pick 100 cars and 100 trucks, that doesn't represent the vehicles driven in the town, so it is not representative. Ruth is studying characteristics of an American popular songs from 1900 to 1945. She obtains a list of 500 songs published during this period. She wants to select 30 songs to include in her sample. Which of these methods will result in a random sample? All right. Method A. Choose the first 15 songs and the last 15 songs. Well, that's not really giving everybody a random sample, because it's just the first and the last. Number the songs from 1 to 500. Use a computer to generate 30 random 3-digit whole numbers between 1 and 500. Select those songs. Does everybody have an equal chance of being picked if you use that method? Yeah. And then let's look at C. Choose a number from 1 to 5 by drawing a slip of paper from the hat. Beginning with that number, choose every 10 songs on the list. Well, let's think about it. This one sounds good. But if I pick number 1, and I'm only picking 15 songs, I have to choose every 10th number. So if I do 1, my next will be 10, then 20, then 30, then 40, then 50, 60, blah, blah, blah. Only go up to 150. So, do the numbered songs that are from 151 up have any chance of being chosen? No. So, that is not a representative or a random sample. B will be. Same thing here. If you're not listed in the first 15 or last 15, you have 0 chance of being pulled. All right. There are many reasons why a sample might be biased. Perhaps the most popular is not representing adequately or at all. In surveys, the people who are not included may have opinions that are not reflective of the sample. All right. A park ranger estimates that there are 4,000 birch trees in a forest preserve. She wants to check a sample for possible insect damage. She selects 100 trees that are planted along the access roads. Is this sample representative or biased? Well, it's biased. Why? Because for a sample to be random or representative, it needs to have every tree would need to have an equal chance of being picked. Here, she's only picking 100 trees that are next to the road. So the other trees deep in the forest have no chance of being picked. Now, think about this. If you're studying these trees, if they're next to a road, that's going to affect the sunlight they get, that's going to affect the water runoff, blah, blah, blah. So you can see why if you don't have a good representative sample, your data may be off. All right. Selecting a random or representative sample makes it more likely that the inferences made about larger populations can be accurate. Inferences often involve proportional thinking. For example, if 1/3 of the people in a sample representative sample have ages under 20, you can estimate that 1/3 of the people in the population are probably younger than 20. So, a large high school has 3,000 students. During a 1-week period, 75 students were selected at random at various times during the day. Each student was asked if he or she had 1 or more social media accounts. The survey found that 3 out of 75 did have a social media account. Estimate the number of students in the entire school who do not have social media. So, let's set up a proportion. They're saying that 3 out of 75 did not. We want to know X out of 3,000. What is our cheater fraction? Isn't this the part out of a whole? 3 is the part that didn't have out of 75, X out of 3,000, and you will get 75x equals 9,000. Divide those sides by 75. And you get x is 120. 120 students probably do not have a social media account. And it's an estimate, an inference. We're making an inference. Each month, a manufacturing plant makes 14,500 light bulbs. Last month, a random sample of 200 light bulbs found that 2.5% were defective. So, estimate the number of defective bulbs that were produced last month. Well, if 2.5% were defective, the first thing I need to do is figure out how many that is. So I'm going to change 2.025 times 200. And you get 5. So 5 were defective. So 5 were defective out of 200. We want to know how many are going to be defective X out of 14,500. Cross multiply. I'm going to have 200X equals 5 times. Divided by 200. And I'm going to get 362.5. So, probably 363 defective. Now, there's another way to do this. And it is quicker, and it is easier. If we know that 2.5% of the bulbs are defective, couldn't I just multiply 2.5% times 14,500? So 0.025 times 14,500. Get exactly the same thing. And that's probably quicker, but you can change it to a proportion if you want. All right, a large university has 24,000 students. A randomly selected sample of 750 students were surveyed and asked how far away they lived from the university. Of those surveyed, 120 lived more than 500 miles. Based on the survey results, what is an estimate of students who live within 500 miles? Now, this one's tricky. Live within 500. So, 120 out of 500 live more than 500. So wouldn't everybody else live less than 500? So we need to do 120 out of the 750 were surveyed. 120 live more than 500. So 750 minus 120 is 630 live less than 500 miles away. So if we want to set up a proportion, so 630 out of 750 live less than 500 miles away. We want to know X out of 24,000. I know that you can solve this. I'm just going to do it quickly here. You end up with X is 20,160 students live less than 500 miles. And that's an estimate. We're making an inference. A TV programming manager wants to conduct a survey to determine which reality television show is the favorite of viewers in a certain viewing area. He is considering 3 samples shown. Draw an X through the 2 samples that would not fairly represent all the people in the viewing area. All right, so pretend you're doing this viewers in Boyertown. That's the population. And the first sample says 100 people that are trying out for a reality show. So if they're having an audition for a reality show and people are standing in line, don't you think those people are probably going to say they like reality shows because they're standing in line for one? Not everybody's standing in that line, so not everybody has an equal chance. So that is no good. 100 students at your middle school. Well, remember, the population is everybody that lives in Boyertown. Does everybody in Boyertown go to our middle school? No. So it's not a random sample because not everybody has an equal chance. Every 100th person at the shopping mall. Pretend there was a shopping mall in Boyertown. And I just stood there and I interviewed every 100th person. Well, that would be a better sample than these 2. It might not be great because not everybody might go to the shopping mall, but it is way better than the other 2 for getting a random sample. So we'll go with